All right, example 5. Find the frequency of f of x equals 4 sine of 2/3 x and explain what is happening graphically. So we said frequency on the previous slide was the absolute value of b over 2 pi. I think at least not on the previous slide, a couple slides ago. And so b is this number in front of x, so it's 2/3 on top. Since it's already positive, that absolute value keeps it positive, over 2 pi. And so to actually work this out, we would have 2/3 times, this is like 2 pi over 1, so we flip up our fraction and make it 1 over 2 pi. Our 2's cancel out, leaving us with 1 over 3 pi. So that means, if we explain what is happening graphically, well, this, because it's 2/3 and it's on the inside right in front of x, that's a horizontal stretch of the reciprocal, which is 3/2. And so what's happening is that we'll have one sine curve at 1 over 3 pi. All right, Hazelwood's over here with us now, and we were talking about the frequency of this was 1 over 3 pi, and that's the reciprocal of the period.
Right.
We're saying that this is going to complete one sine curve by 3 pi. That's what this means. So graphically, we've got a horizontal stretch of 3/2, because normally it completes by 2 pi.
Right.
3/2 of 2 pi is 3 pi.
Yeah, and you can look at this on your graphing calculator too. Like, this is kind of a, frequency can be a little bit of a tricky monkey to try and
wrap your head around.
Yeah, and so if you
Why
will,
would you wrap your head around a monkey?
Really awkward. So what you can do though is put this on your calculator and just look at your calculator, tell the x-coordinate to be 3 pi, and see where it goes on your graph, and it should line up to show you that it's a completion.
It should indeed. You want to talk about how to graph this?
Great idea.
Okay, so what's happening here, the way we graph a sine is we need to look at two things. We've got this amplitude of 4, which means that our sine curve is going to go as high as 4 and as low as -4.
Every time, period, without fail.
Okay. 2/3 here, we just said that the frequency is 1 over 3 pi, or the period is 3 pi, okay, which is important. So if we hadn't been asked the frequency, we would have done 2 pi over 2/3 to find that that's
Right.
3 pi. And so what I normally do is I normally make like a, let's make this 3 pi out here, and let's make this -3 pi. And the way I like to do it is divide it up into fourths. Is that how you roll?
Wow, I roll the exact same way.
Halfway between 0 and 3 pi is 3/2 pi.
Oof. 3/2 pi. I know it's a fraction, but it works out perfect. That's the beauty. That's why dividing into 4 is so amazing.
And then, should we find those tick marks, or are we just fine with having those tick marks?
I'm fine with having them, but if you took half of 3
pi over 2?
3 pi over 4.
3 pi over 4. Okay, we don't necessarily have to label all of them though. Just if we divide into fourths, we have to remember that sine starts at 0. And if it's a positive sign, which
it's going to go up to 1.
It goes up first.
But in this case, 4.
Right. In this case, 4. So what happens is we have to be back here at 3 pi. Halfway will be at 0. And so we've got a hill, and then we've got a valley. Which that last valley there looks a little awkward, but hopefully you guys
it's all
will
good in the
forgive me.
neighborhood.
And then just go backwards here. Okay, but what was important is really labeling it was important.
Right.
We had to go up to 4 and down to -4. We have to have one sine curve, which means one hill and one valley by 3 pi, and that's it. That's how you graph a sine curve. If it was cosine, we start at +1 if it's positive.
Right.
Start at -1 or -4 if it's negative.
You got it.
So
just use your general. Hey, you can use one of these bad boys too while you're learning.
yeah,
Always helpful.
Yeah, to make the connection there. But the thing with the calculators, it's not going to tell you these in pies. You're going to have to figure those out yourself. Like for 3 pi, it's going to have like 9 point something.
It'll be some really weird deal.
So,
So you do have to have some patience, but it is possible to to graph by hand fairly easily and then double check on your calculator.
Right. You ready to do example 6?
Yeah, let's rock it.
Right, the cosine function as a phase shift of the sine function.
Ooh, a phase shift like Star Trek.
Phase shift is a fancy word for a horizontal shift. Right?
I like Star Trek better.
Okay, well, it has nothing to do with Star Trek.
But it sounds cool.
Okay.
Phase shift.
A normal sine curve.
They line up like this.
Normal sine curve.
Here's the sine curve, here's the cosine curve. Notice how my hands are not quite identical, but they are the same. And phase shift, we're going to take what's different and line them up so that they're identical, that you can't tell the difference. Look, she's drawing it out right now way better than my hands will ever go.
This one is cosine because it starts up at 1. The other one was sine. And so we're trying to write the cosine function as a phase shift of the sine function. So we're trying to do y equals sine of something. Okay, since we're talking about a phase shift, which is a horizontal shift, it's going to either be adding or subtracting something to
It's
this
exactly
x.
like what you did with all the previous functions that you've worked out where we've had to move left and right. It's
Exactly.
the exact same thing.
Exactly. So what we're doing is cosine, which is what we're trying to write as sine. All of these points are what? This is pi over 2. There's a difference of pi over 2.
Difference of pi over 2.
And really, we can make it either negative or positive because either we can say, oh, well, it's going this way, or it's actually, is it going backwards? No, going backwards is not the same, but not pi over 2.
Right, not pi over 2, but it would be
right
more.
pi over 2,
Right.
which means minus pi over 2.
There you go. That's it. That's all there is to
And
it.
that's what it's asking.
You got
us.
it.